Chapter 6 is about a topic called factoring. And in math there's many inverse operations such as adding and subtracting, multiplying and dividing, if you take the square of a number versus if you square root the number. So factoring is actually the inverse operation of distributing or foiling. So in the last section, or last chapter I should say, we were distributing numbers and we would get this as our answer. Here, that's going to be the question, and we have to work backwards to get this as our answer. So it's really the reverse of distributing. Also, it's the reverse of foiling. So in the other previous chapter, we did first, outer, inner, and last to get this trinomial. So now we're going to start out with that trinomial, and we have to work backwards to get the original two binomials. So this whole chapter is really reversing everything that we did in the previous chapter. Factoring doesn't actually change the value of the polynomial, it just changes the form. And this factored form is going to be used for solving, and for simplifying. So there's going to be many situations where we're going to need to use factoring to solve equations or use factoring to simplify different things in later sections. Okay, so the first factoring rule is always to factor out the greatest common factor. So this is our rule number one. This is one of the most important ones. The greatest common factor is the greatest integer and the greatest power variable that divides into each term evenly. So factoring is actually very much like division. They're very closely related. So an example would be to factor the greatest common factor from 25x cubed plus 15x squared. So the largest number that divides evenly into both 25 and 15. So I'm looking at my two terms, and I'm going to first look at the regular numbers, 25 and 15. And the largest number that divides evenly into both of those is 5. Now I want to look at the variable part of my two terms, and that would be the x's. And the largest power variable common to both x cubed and x squared is, well, it's actually x squared. Meaning x cubed has 3 x's, x squared has 2 x's, but they both have 2 x's. This one just has one more, but 2 x's are common to both of them. So it's the highest one that goes into both of them. Therefore, the GCF, if I combine these two, is going to be 5x squared. So if we factor or divide each term by this GCF, we get 5x plus 3. So if you kind of want to see that the long way, 25x cubed over 5x squared plus 15x squared over 5x squared. So every term we're actually dividing by this GCF. And that's going to get you, well, 25 divided by 5 is 5. X cubed divided by x squared, we subtract those, so that is x, or x to the 1. And then 15 divided by 5 is 3. And then the x squareds go away. So this is where they get this. Now, that's what's left over, but in the final answer we still need to put the GCF on the outside here. So the final answer would be the GCF times what's left over. Because again, if you think about it, we're reversing a distribution problem. Meaning you need to have the thing on the outside multiplied by the leftover. And then also this is kind of a way that you can check your work. So if you want to check your work, you could always redistribute the 5x squared to both of those terms. Okay, so it says for number 1, factor out the greatest common factor, or what's called the GCF, from the polynomial. So if I look at my 3 terms, let's look at the regular number, or the coefficient. We have 9, 18, and 6. The largest number that divides into all 3 of those is 3. Then if I look at the variable, or the x's, I have an x to the 4th, I have an x cubed, and I have an x squared. So I'm really only as strong as my weakest link, meaning I'd like to take out 4 x's, but I can't because these ones only have 3 and 2. I'd like to take out 3 x's, but I can't because this one only has 2 x's. So they all have 2 x's. Some of them have more, but they all have 2 x's. So I can take out an x squared from that. So then I'm going to put a big open parentheses, and I'm factoring out this 3x squared. So I need to put what's left in each term. So if you factor out a 3x squared out of 9x to the 4th, again, it's the same as dividing by it. So 9 divided by 3 is 3, and then I had x to the 4th. I had 4 x's. I took 2 out, so I have 2 left over. With the 18x cubed, 18 divided by 3 is 6. I had 3 x's. I had x to the 3. I'm taking out 2 x's. I'm taking out x squared. So I have 1 x left. And then lastly, looking at the third term, 6 divided by 3 is 2. And then I have 2 x's. I have x squared. But I'm taking both of those out. I'm taking an x squared out. So there would just be a 2 left here. And that would be my final answer.